Try SLT3. Try
All right, afternoon. Welcome to COMP2190 Session Computing. I'm Dr. Coco. Okay, I typically start all of my courses with a lecture 0, okay, which basically gives everyone an overview of the course. In a sense, this is a lot of the materials that you have in the syllabus, which is on OERDLE. This is also on OERDLE. You can go through and read this, read the syllabus as well. Okay, I expect that you would have read it. I spent some time working on it, and I expect that you would read it. Okay. So the outline of this talk will be as follows: talk about that I just did welcome. We'll talk about the aims, rationale, the learning outcomes, a high-level overview of the course. My teaching approach, I'll talk a little bit about the course readings and the assessment. Okay, so just a sense. And you can stop me and ask if you have questions. So what this course is, it basically covers a wide range of subspecialties, including computer networking concepts, so mobile and wireless computing, distributed systems as well. What happened around 2008 or so, the ACM, which hopefully you guys are all familiar with, the Association of Computing Machinery, in their curriculum recommendations, they realized that computer networking is very important to modern day computing, and so it became a core concept instead of an elective concept like it used to be. So what I'm going to, because of this, it's important to expose you guys, if you would, to important aspects of secure systems development. We'll also talk at a very high level about cryptography, intrusion detection, malware detection, and web technologies. Okay. So the internet, as you guys are well aware, is very important. By the way, the internet is more than the World Wide Web. Okay. The internet existed, well, some of the networks that formed the internet actually came into existence about 1969, right? And academics used the internet for years, but what caused the internet to take off was the World Wide Web. Sir Tim Berners-Lee was working at CERN at the time, and basically developed HTTP, the Hypertext Transfer Protocol. And with that, the web took off and the internet became popular. It entered modern day consciousness. But remember, the internet is more than the web. Anyway, so for example, the internet is driving educational change. A few years ago, there was a lot of excitement around MOOCs. You guys know what a MOOC is? Anyone seen this acronym? How many of you can see this, by the way? You see that? No. What about this? No. All right, well, I may. Anyway, so these are actually new markers. So, all right. Well, MOOCs were very popular. Turns out people thought they would replace universities. They would not. You can actually go online and take courses from leading universities. Okay, people have you won't get credit at the universities, but you can get the content. Okay, that's facilitated by the internet. Economic change. This was an article on the BBC, basically talking about how work patterns were changing, in part because of the internet. For example, you have programming teams, sometimes built from persons working, say, in the US and say India or something like that. They're working on a problem, right? So that's facilitated in part by the internet. People can communicate with each other. They can ship work back and forth. Driving political change. This was an example of a few years ago and they had protests after one of the presidential elections in Iran. Twitter was being used to organize people to protest. Okay, another thing facilitated by the internet. This also an article on the BBC talking about what cyber war would look like. Right? These days, the internet permits other countries sometimes to sabotage an enemy nation's computer systems, even its government systems, without actually, landing or occupying that country. Facilitated again by the internet. So, all of that basically to kind of drive home this point that computer networks are very important to modern life. And so it's important to know how to design and implement networks and measure their performance. And as I mentioned earlier, the ACM IEEE Computer Society have now made net-centric computing a core requirement for an undergraduate computing degree. Okay, any questions so far? So by the end of this course, I would expect you guys to be able to discuss the evolution of early networks and the internet, to be able to explain the hierarchical layered structure of a typical network architecture, look at the protocols that you're going to use between different network applications. We'll look at, in this course, we'll look at HTTP, which, as I've mentioned, we use with the web. We'll look at DNS, which is like a phone system, if you would, for phone book for the internet. Then we will talk about the responsibilities of the different layers that we have. Okay? Yes?
So is there any time short course you'll be using Kali?
You'll be using what?
Kali.
Okay. Excuse me. I am giving you guys this thing. Let's see what happens here. I don't know what happened, but okay. So there was a question about Kali Linux. Your first assignment, I will have you guys run a few Linux command line utilities, but I don't require that you use Kali Linux or something like that, okay? If you want to do that, that's fine, but that's really not the point of the course. It's actually to run these commands. So you guys should be able to describe the responsibilities of the different layers in our 5-layer model, which we're going to talk about. Then we'll discuss at a very high level how a network can detect and correct certain transmission errors using one's complement addition, basically. You will describe at the very high level how a packet is routed across the internet. You will be, we'll work through a few examples of that, and you guys will be able to do that, should be able to do that, okay? You should also be able to identify the protocols that are used for internet communication, and then choose the correct protocol for a given case. Discuss intrusions and intrusion detection. Then talk about the fundamental ideas of cryptography. Okay, and we're going to pay particular attention to public key cryptography. I'm going to have you guys, as part of one of your assignments, you guys are going to generate a public-private key pair. If you don't know how to do that, that's fine. You will be able to do it when the time comes. And then you will, should be able to describe and discuss successful security attacks, and then summarize the strengths and weaknesses of different approaches to security. And then the third part of the course, we're basically going to be looking at web programming. So there are 3 parts to this course. There's networking, which will take roughly 7 weeks, 7, 8 weeks of the semester. And then we'll talk about security for about 2 weeks, and then talk about web programming for the last 3 weeks. Okay? So at the end, the objective would basically be for you guys to design and build a simple interactive web-based application that would have some fundamental security considerations. And then you should be able to describe some emerging technologies with respect to net-centric computing. Okay? So those are the outcomes. If you would keep these at the back of your mind, because you're going to things that are going to assign tests to you guys, I'm trying to make sure that you guys do these things. Okay? These are the things I think you should be able to do. So these are the things that I will be testing. Okay? So, at a very high level, this is what we would look at. So look at network architectures, then talk about delay, loss and throughput in networks, talk about the network protocols and layering, and then talk about network standards, and then background and history of networks and the internet. Then we're going to look at the application layer, and there we're going to pay attention to web protocols with emphasis on HTTP. Talk about DNS, the domain name system, which, as I said, is like a phone book for the internet. And then we're going to do some socket programming. Okay? So brush up on your Python in case you have begun to forget. Okay? We are going to use Python, certainly for our first 2 projects. Then we're going to move to the transport layer. And there we're going to talk about what services are provided by the transport layer, talk at a very high level about UDP, and then talk about TCP, the transmission control protocol, which is used to have reliability. Basically, you don't have any data loss. You're trying to transfer from one party to the other. Then we'll talk about the network layer and talk about IP addresses, okay, IP version 4 addresses, and then we'll talk about network address translation. Basically, okay, most of you have computers at home, right? Smartphones. And typically, your ISP will give you how many addresses? Typically at home. 1, right? But many of you have multiple devices at home, right? That's all possible because of network address translation. So we're going to talk about that, and you guys will understand that hopefully. Then we'll talk about DHCP, the dynamic host configuration protocol, which is basically a way in which you get an IP address from your devices. Okay, so we'll talk about that. And then we'll talk about IP version 6. IPv6 is the next generation of IP. It's being rolled out because we've run out of IP version 4 addresses. Then we'll talk about the link layer and local area networks. That's what LAN stand for. And so we'll talk about, have an overview of physical and data link layer concepts. Then we'll spend a bit of time talking about Ethernet, okay? And that's where we're going to talk about how a packet gets routed through the internet, if you will, okay? Then we'll talk very briefly about wireless computing, and that does it for the networking concept. And then we'll talk about network security. And so here we're going to talk about the fundamentals of cryptography, okay? Then talk about secret key cryptography, public key cryptography. And then talk about how we authenticate another party. Authentication is basically making sure that the person you're talking to is who they claim they are. Okay? Now, why might that be important in the context of networks? How many of you do online banking? Okay? Now, when you're doing online banking, would you like to be sure that the computer that you're talking to is actually a bank server? So you need a way to authenticate that machine. Okay, so we'll talk at a very high level about how we authenticate machines. Then we'll talk about different types of network attacks, and then how we defend against those attacks. Okay, and then the last part of the course, as I mentioned, deals with web technologies. So we'll have some basic client-side programs. That's what we're actually going to start. So just write some simple XHTML, simple style sheets, very basic JavaScript, and then talk about PHP and MySQL, and that should bring the semester to an end. Okay. Any questions? All right. The slides will be online, okay? But I expect that you will take notes, okay? And that you will prepare for class. Preparing for class means, at the very minimum, looking at those slides before you come to class, okay? We're going to have lectures Mondays and Tuesdays, okay? So we're in the 12 to 1 p.m. slot, and we'll have a lecture as well tomorrow, same room. There are tutorials every day of the week except for Friday. Wednesday seems to be the heaviest day. This is tentative, but these should be the tutors. They're all students. I thought they did the tutorials last year. They're very competent. Okay. Eight to 10. 9 to 11? I mean, I first. Okay, I'll check. What's that? I'll check. I go where they tell me. I don't set the timetable, so. if they tell me that I'm teaching at 8, I show up at 8. Okay, I'll check. Okay. Sorry? Okay, I'll check again. We've gone through a few drafts of the timetable, so. All right. I'll check it. I said I will check it. Right? So if it says 9, then it's going to be 9, right? I'm not going to check. All right. The my way of lecturing, I'll try to ask questions, okay? So we can actually have engagement with the material. Educational research actually says students draw on the material that they have, they actually remember it better. Okay? So part of that means the way I start my classes is also with a review of the class, the previous class, and I tend to ask students for what was covered in the class, not because I don't know, but because I want you guys to remember. Okay? I will try to stop. I don't like to stand here and drone the whole time, so I will stop sometimes and ask questions from you guys. Okay? I am actually thinking this semester of recording at least some of the lectures, and if I do that, that means what will happen is that you guys, my expectation is that you're going to actually watch those lectures on your time, And when you come to class, then we're actually going to be solving more problems. Which also means I will be asking you guys questions. Okay, I'm not just going to sit with my back to you guys and solve a problem. I'm actually going to ask for answers from you guys. Okay, any questions? My expectation is that you attend class, you participate, and that you're courteous to me and your peers. Part of that courtesy is trying not to have sidebar conversations while I'm here talking. Okay, I do see it. Feel free to ask questions and sometimes bring answers. Right, I welcome that. So, a few rules for the class. Please turn off your cell phones, or at least put them on vibrate. I will use a tool called, yes, your phone off, please. Yes, you with the arsenal. Okay. I will use a tool called MOS, okay, to run all your programming submissions against. Okay, so please do your work yourself. Okay. I don't like to invite students into my office, so make sure you do your work. The work that I give you, I am pretty certain you can do, and I give you more than enough time to complete. Okay. You are responsible for all the materials that we cover in lectures and tutorials, whether or not you're present. If you're not present, it's your responsibility to go to one of your peers and figure out what was covered on a given day. Okay. Attendance at lectures and tutorials is not required, but my experience has shown that students who come to class, go to their tutorials, tend to do well. Students who don't, tend not to. In the same way, students who tend to actually do their programming assignments do well. Okay? Let me expand that definition of doing well on programming assignments. So maybe you get someone to write your program for you. Okay? If you get come across a problem on a test, for example, that is based on a programming assignment, if you didn't do it yourself, you have a problem. Okay? I actually had a sad case like this over the summer where there's okay. So do your work yourselves. Ask for help, but make sure any work that you turn in is your own work. Okay? I don't typically give extensions within 24 hours of due date of an assignment. Typically, two reasons for that. I typically give you guys more than enough time to complete the work, and also because it's unfair to the persons who have completed the work already. Okay? So once we're within 24 hours, I typically don't give extensions. Lateness policy, by the way, I use OERBLE heavily, okay, for this course. So all your assignments will get collected up to OERBLE and so on. What happens, my lateness policy, once the due date passes, first 24 hours, you get a 10% penalty for your assignment, okay? And then between 24 and 48 hours, you basically get the 20% penalty and so on. 5 days after the due date, I don't take your work because you're going to fail it anyway. Okay? So, and you can still upload. OERBL is actually configured to allow you to upload your assignments up to 5 days after that, after the due date. Okay? Any questions?
All right, sir.
Yeah.
Sir, we're supposed to upload it like an hour.
What was the due date? What's that? It's very short, right? It's after the due date, is it? What's that? Suppose it's like 1 second. I do use discretion, but OERBLE will mark it as late. Right? It's true. By the way, let me give you guys an example. The real world moves on, right? And the real world, this weekend I was working on a conference. Paper was due at 6:59 local time. Guess what happened at 7 o'clock? the portal closes. There's no option to even upload it. Okay? This is me, and I can't go and write to a program chair and say, hey, can you think this is 2 minutes late? It's a second late. The portal is closed. No one is going to entertain it. Okay? So, hey, the lateness policy is somewhat flexible, right? I do use discretion, but the point I'm trying to make is that the real world is actually quite unpredictable. Okay? So the due date is there. Okay? Now I give you, so let's just pick an assignment. I may give you 10 days. May I give you 30 days? I'm giving you 10 days, right? And I have the expectation, okay, maybe you might have to learn some things, maybe it's going to take you, 4 hours. But I'm giving you 10 days, right? It's time for you to work on this, upload things before. I realize things happen sometimes. Last year, for example, I think it was a hurricane or something. There was something with the due dates. Or maybe some students complained about wireless access on campus. I could see that. I could work with that. I waive the penalty for persons. I understand, right? But don't skate on the margins. Okay. Any other questions? Quick but nice. Plagiarism won't be tolerated. By the way, university policy. I actually have the university's policy on plagiarism in the course container. Read it. What's that? What's that? How expensive is the lunch? Okay, raise your hand if you're asking me something. I'll try to find it. Sorry? Is it a large lunch? No, we'll probably take you out to a restaurant somewhere. Okay, and I will write recommendations. Students who work hard. On a bit of plagiarism, I mean, I answer. This is an example of output that I get. Okay, so I go through, I run your assignments, and it tells me, for example, what the matches are. I don't know how well you can see, but yeah, right there, you can see right there. There's 99%. Basically, it's saying 99% of the code in this file is similar to that one, and saying 96% of the code is similar. Okay, tells me how many lines match, and I can click through that, and it actually shows me the matches. Okay. Changing variable names will not work. Okay. This is stuff from stats. Sorry? That, I mean, do your work, okay? If I give you start the code, I can actually tell it to execute that stuff. Sorry? You can't buy it? No, you can't buy it, but you can go online, Google Mods, you'll find it, okay? It's web-based. Yeah. Okay? So, if you're curious, you can Google it. It's all web-based. Just remember, I have access to a lot more code. All right, textbooks. This is the primary textbook. Computer networking, a top-down approach. Version 6, okay. If you have access to the 6th version, it's okay. Last year, once we had that, I was able to post the mapping about what's in it. For the purposes of this course, the differences between version 6 and version 7 are okay. Okay. Sorry? A PDF? No. This is all on OER. Hey, this is I know sometimes students complain. This is actually the top-selling computer science textbook outside of an introductory textbook. It is used at places like Stanford, University of California, Berkeley. Okay, lots of universities, University of Massachusetts, one of the authors teaches there, New York University, and so on. Very popular, very good. To be clear, because this seems to be an ongoing thing every year, you are not required to read the entire text. Okay, I'll repeat that. You are not required to read the entire text. Yes, obviously. I wouldn't have you buy the textbook to put it at a doorstop. Yes.
So I can first see you.
I don't recall. You can Google it. Okay. In your syllabus, on the syllabus online, there is a listing of which sections of the book you're supposed to read for each week. Okay. What's that? Each week, yeah. All right. So that is what you're supposed to do. So do that. When we get to the web programming, so this is basically what we're going to do for the first two parts of the course. When we get to the second part of the book, the course, or third part, I'm not going to have you guys read specific sections of the book, but if you guys want the textbook, this is what I will be referring to. Okay? Web programming step by step by Step It Out. Okay? Yeah. Okay. Any questions?
So do you know what your company?
No. Because I need it. All right. So part of it, the reason I have you guys read is so that you guys can actually understand what is going on in the course. Okay. So you can also make the most of your tutorials and these classes. Okay. And basically deepen your knowledge of the material. There are going to be 3 programming assignments in the course. The first project is these are all programming projects. Going to be an application layer project, socket programming. The second one will be something to do with cryptography. We're going to talk about cryptographic algorithm, and you guys are going to implement it. The third part of the project will be based on web technologies. It's going to be a very basic something. I'll have you guys design a form, take data, okay, validate it, and store it in the database. Okay? Stuff that you guys do all the time. Okay? And you guys will use style sheets and so on. Assessment. We're going to have an in-course test about week 6 or thereabouts. Okay, that will be worth 10% of your grade. I intend to give you guys quizzes. Okay. There will be one course. One of those quizzes will be on OER-BLE. I think it's quiz 0. Yes. Approximately. And then I'm going to give you guys a quiz each week in class. Typically, it's going to be on Tuesday. I used to give the quizzes on OER-BLE, and anyway, 2 years ago, I decided to do it in class. There was issues with people having the quizzes on OER-BLE and so on. I didn't think it was effective. So I did it in class, typically, just a small sheet of paper, typically tied to something that was covered over the previous week, and something that you guys can complete in 5 minutes or less. Yes, sir. If you miss that quiz class, if you have a conflict, come talk to me and we'll see. Okay? That is that. If you miss it, if you're ill or something like that, you talk to me. If you miss it just because, right? But if you're sick or something like that, I understand. You come talk to me. We're going to have written assignments. I think it's 2 actually, not 3, but you get one, I think next week, thereabouts. And then the other one will come at the end of once we finish talking about networking. And then the programming assignments, we talk about that. Those will account for 25% of your grade, and your final exam is 50% sometime in December. In accordance with typical practice of the Department of Computing, you have to pass the coursework and the final exam separately. Okay, nothing new, just have to. And so pass mark 25. Okay, either component. Oh, and if there's anyone who's repeating, of course, practice with the department is that we don't carry coursework forward except for the summer. Okay, so if you're repeating, you have to redo the coursework. And you should do better because of that. This is the university's grading scheme, which I have here. Right? You guys are all familiar with this, right? A plus 90% and so on. All right.
Right? Is it that, like, when we have a course every week, if you get an A plus every week, you get lunch every week?
My pocket won't support that. No, that's the A plus at the end of the semester. Plus, the typical weekly quizzes will only have like 3 marks, right? So, giving a quiz to that, big deal. Right? Do it at the end. When you basically, I'm rewarding consistent performance. Yes. Oh, tutorials are different. The quizzes that I give will be done in class. I'll have a oh dear. Okay, well, I will have a small sheet of paper. I spent all my morning cutting these sheets of paper. I have a small sheet of paper. I'll have think of half of a letter size sheet. There will be a question, and typically there will be multiple versions actually, all testing the same concept. And I'll hand them out in class. You get, 5 minutes, no more than 5 minutes. All right. Yes. Okay. Well, I don't know what you mean by knowledge base, but. Sorry? Like theory? Okay. As a general rule, by the way, as a general rule, I don't ask questions that will say straight recall questions. Okay? The questions that I like to ask are questions that will cause you to apply the knowledge. Okay? In the real world, guess what? People are more interested in you applying the knowledge that you have. Okay? No one is really interested in you doing a brain dump of stuff that you have that's. But given what you know, here is a scenario. What do you say about this? Okay? So typically that is I suggest. Sorry? No, do we do any pen testing in this course? No. The course where you would see pen testing is Info 3155. The third year course, which depends on this course. Okay? Pen testing, for those of you who may not know, is penetration testing. Okay? What's that? Everyone knows? You'll be surprised. What? Penetration testing? Where you try to break into a network or break into a host. Okay? So you try to break into a network or break into a host. So typically, Yeah, so typically when, for example, say a bank or something like that, might set up some online banking server, they might actually go sign a contract with the company to do some penetration testing. Okay? So, all right. Are we doing on time? Oh dear. This is what the grade distribution for this course looked like last year. Okay. What's that? Anyway, that's what it looked like. Historically, what's that? Yeah, what about? Sorry? Did I buy any lunch? I mean, so for the record, 3 years ago, I had a student who had 99% of this course. He's at Google now. A student got 99% in this course. What's that? He works at Google now. He was hired straight from UE to go to Google. Historically, this is what the performance in the course looks like. Okay. So first time the course was offered, pass percentage was 66%. Then this point, that was the low point. That's when the pass mark changed from, it used to be 40%, changed to 50%. We had a drop, went up. That was because I introduced the quizzes in class. That's why actually I thought it worked well. That's why I continued doing it. That was last year. By the way, I want you guys to do well. Okay? I want people to do well. If you do well, I'm very happy. I don't have to do it. No, I really do. I really am. For example, I taught the course last semester 2, 90%. The one student who failed hadn't been doing coursework anyway. I was disappointed by that. But I mean, remember, at the end of the day, your performance depends on you. Okay? Just so you can, this doesn't show much better. This shows you, basically, gives you an idea of the distribution of the coursework marks. You probably can't see well that over this year, that's one student got 50 on the coursework. The student got 49 on the coursework last year. That's what that outlier is. These are all outliers. That's the 50 on the 49 on the exam that year. Okay. Again, it's an outlier. All right. Now, I am aware that this course has a reputation. Okay. So one of the things I did this year, I decided, well, let's change it a little bit. I said, okay, let me talk to a few students who have taken this course, done very well, and they've graduated. So here is one. This is a student who graduated at 99%. And so this is what, by the way, he graduated with first class honors. Okay, and he was recruited. What's that? Right. Why that? Of course. Why, of course. But that's one course. But that is one course, right? But I mean, he did well consistently. But okay, so here, this is what he said. We prepared for a lot of content. Course involves a lot of important concepts that build on top of each other. Right? The stack protocol, for instance. So read the slides ahead of class, at least in them, and attempt all tutorials or assignments well ahead of time, as they are meant to solidify a point and not just grades. That is true. If you're really interested, read the textbook as much as possible. The problems and how they're solved are very fascinating, but the slides are pretty comprehensive. and read about the content on the internet from different perspectives. This is important to cement knowledge and applications. Okay, that's what he said. And he says, I mean, you know, this was an email, said, why should you do all of this? Well, computers today are only as powerful as they are because of networking, which is true. Otherwise, they're really just big calculators. And networking evolved over time from being something the military created to powering so many revolutions through the internet today. And it's an amalgamation of many aspects of computer science, from algorithms to systems designing to even hardware designing. And he points out that it's actually fascinating to see a high-end switch. That's what is basically going to move the packets around the internet. Not only will you learn about how networking is done today, you will also learn about how such a complex problem was tackled, and this will lead you to solve similar problems that you encounter yourself by applying the design patterns that you learned. Okay? Last year, I actually invited him. He came on vacation. I invited him to speak to the science students. And one of the things he said, he worked on an app which has been rolled out in many of the Android phones now. And, sorry? I don't recall that. I back up and restore whatever. But it's basically to allow for transfer of information from an old phone to a new phone. But he was talking about in his team, when they were splitting out the work, you know, he immediately raised his hand to look at the transfer of data using TCP because he understood that from here. Okay? So you guys can actually learn things from here and do quite well. Okay? This is another student. I took this course 2 years ago when I introduced the course, the quizzes, in-class quizzes. And you know what he said, as you're about to undertake 2190 this semester, you have no doubt heard the idle talk about the ridiculous levels of difficulty that this course entails. While the course is far from easy, if you do the following, as a rule, you're almost guaranteed an A. Obtain a copy of the textbook and read the section relevant to what you'll be covering in lecture ahead of time. This will allow you some leeway when the work will become so heavy that you begin to skip lectures. Attempt every question on the tutorial sheet ahead of time, no exceptions, and do not under any circumstances miss tutorial session. Ensure you attend the tutorial. Take the weekly quizzes seriously. 5% is a static relative, like I said. But it will seem much greater at the end of the semester when you need it more. It's basically 3 marks. Obtain all the past paper questions you can and attempt them during the semester as you're covering the relevant content. Yes, this is a secret. I don't know that. At the end of the semester, when you are preparing for your exams, this course will be a breeze. Bonus point, if you manage to get your hands on some tutorial solutions and use them as an excuse to skip tutorials, you're setting yourself up to fail. The solution to the tutorial questions is useless unless it comes from your own understanding. Okay, that's what I said. I didn't pay him. Anyway, other students, right? You can talk. So my advice to you is experience the course for yourself. Okay? And by the way, this is got first class honors too. Another student who's graduating in October, she I think the course same time she was studying. Last year she was telling me, oh, she wished she had just experienced the course herself. You know, she came in with certain preconceptions and she realized it wasn't that way. Okay? So work hard, do well, I will be very happy. Okay? Any other questions you have not asked? Yes?
Well, it was kind of asked for, but sir, you check the first time before?
Yes, I will. Yes.
Where is your office located?
My office is in the Department of Computing. So on the 3rd floor of that Life Sciences Computing building. If you come in, say going through from the secretary, the front of the department, just walk down almost as far as you can down that hallway. And my door is the last but one on the left as you go down. Okay, I think I said I have office hours 3 to 4 on Mondays or by appointment. Or by appointment basically means you send me an email and say, you know, could I come in and we'll work out a time that works well for us. Okay, but 3 to 4. Other questions? Are we doing on time? Okay. Well, administrative stuff, important. The prerequisites for this course are 1126, 1127, 1161, and 1210. Okay, all four. So make sure that you have all four. If not, request an override. I am not in charge of processing overrides. That's the undergraduate coordinator or the head of department. Okay, but my advice to you is that make sure you have all the prerequisites before you take the course. But that's my advice. Okay. All right. On that note, this is the first time I have any other questions that you're dying to ask that haven't been answered. All right. In the time that remains, I'll do 5 minutes. Okay, so we'll start looking at the first chapter of the textbook. This is actually the only chapter of the textbook that we cover in its entirety because it's fundamental material. Okay? So, our goal is basically to give you guys a feel for networking technology and terminology. You're going to get more depth and detail later in the course, and we'll use the internet as an example. So we're going to look at things like what is the internet, what's the protocol, network edge, host access network, terms basically, network core, packet circuit switching, internet structure, look at different performance metrics for networks, so loss, delay, throughput, talk about security from a very high level, and then talk about protocol layering and service models and internet history. Okay, so what is the internet? If I were to ask you that, what is the internet? What would you say? What is the internet?
Virtual realm.
What's that?
Virtual realm.
A virtual realm. Okay, so we have that answer, a virtual realm. What else? What is the internet? Yes. A connection of networks. Okay. Okay, good. Any other thoughts? By the way, what is a network?
Connections of devices. I would say common devices.
Okay, common devices. By the way, are networks only limited to computers? Common items. Okay. By the way, have you guys heard of a road network?
Yes.
A road network. Yes. Right? What would that? Okay, so what might be the things connecting on a road network? What's that? The highways. Okay, and then what are the vertices? The points. No? The towns, right? Towns, right? That's what you know, places, essentially. So a network, if you would, you know, you have the context of a computer network. You're going to have typically general purpose computers, okay, and then you're going to have links between those general purpose computers. Okay. So what is the fact that they're general purpose? What does that mean? What does that allow us to do? But by the way, when I say it's a general purpose computer, what does that mean? What's that? It's not special? Okay, it's not specialized for one thing. Good, right? You can program it. Okay? Which is in contrast, for example, the telephone network. Okay, you guys like have grown up with landlines, right? Yeah. Yes. Okay. So on a telephone network, what are the edges of the telephone network? Not the edges, sorry, the end devices. Because the phones on the desk, right? Now are those smart or dumb? They're dumb, right? All they can do is call, make a call, initiate a call, or receive a call. Now, Trust, there is a lot of complexity within a telephone network. Where do you think that complexity resides? What's that? Yeah. Inside the network, yes. There's actually the switches and things like that. There's a lot of complexity inside the phone system. Okay? The internet, on the other hand, guess what? We have smart devices on the edges. So what can we do with those smart devices? What's that? Anything you want, yes. So we can program them to do what we want. Which means what happens now with the inside of the network, the computer network. It's a lot simpler, okay? So, what we're going to do, so I'm kind of running out of time. So tomorrow we're going to start by talking about what is the internet, okay? Then we're going to talk about the network edge, is where we find the end devices. And then we're going to talk about the network core, okay? Where we see, a lot of other devices that you don't typically see. All right. So we'll start with that. We will not have a quiz tomorrow, okay? But you have work to do, right? Go and read the syllabus. You can read this presentation as well, and start skimming these slides. Okay. And let me check the class time. Oh, just a minute. Let me check that since we are all here. Okay, so yes, tomorrow's class is from 9. I got the version of the timetable from Friday. It's 9 to 11 in here.
So what modules do like Python and stuff?
Yeah. You want
Sir, you said that you would
actually got it on the
I've been looking at them. What's up with the previous saying? In regards to tomorrow, so quiz is the session.
I typically do it the last 10 minutes.
That's the part I have on.
What's going on?
Yeah, just ask them.
Wait, what?
Very persistent. I can't miss that one because I'm already missing another conflict. It's just
You have the same problem?
The maths is clash. Mathematical analysis is clash with the same. So I think I could be one away and the other one.
It's fine, that's okay.
No, about this is
Send me an email. Okay? Name and of course the same problem? Send me the email. Yeah. Send me an email. You know my email address? First name and last name. Yeah, it should be at the top of
sir,
the
that's why I
syllabus.
was going to that's online.
What's that?
So I was going to the tips.
So the videos will be available for like next week.
I haven't worked that far.
Because when I heard they said that, I was saying that would be good seeing that I would jump 1 hour tomorrow.
I'll try. I haven't worked out that logistical detail yet. Okay.